day, everyone. I'm Miss Flames and one of the reporters for today's discussion. As you can see on the screen, our topic is about the rheologic properties. The first question is, what are the factors affecting viscosity? But first, let us define viscosity. The viscosity of a fluid is a measurement of its resistance to flow. This term describes the internal friction of a moving fluid. Because of its molecular makeup, a liquid with a high viscosity opposes motion because it has a lot of internal friction. When fluid has a low viscosity, it moves readily because its molecular nature causes very little friction. Gases also have viscosity, although it's a little difficult to observe in everyday life. The unit of viscosity is poise, named after Poiseuille. Factors affecting viscosity. First, temperature. The increasing temperature on the sphere will slow down in gases and accelerate in liquids. At room temperature, the molecules of a liquid are firmly bonded together by attractive intermolecular forces. The viscosity is caused by these attractive forces, making it difficult for individual molecules to move since they are strongly bonded to their neighbors. The kinetic or thermal energy of the molecules increases as the temperature rises, making them more mobile. Because the attractive binding energy is reduced, the viscosity is also reduced. If you keep heating the liquid, the kinetic energy will exceed the binding energy, causing molecules to leave and the fluid to turn into vapor. Next, chemical composition. The viscosity of liquids generally depends upon the size, shape, and chemical nature of their molecules. It is greater with larger than with smaller molecules, with elongated than with spherical molecules.
Next is colloid systems. Colloid systems have different viscosities compared to the dispersed medium. Diaphilic colloids is surrounded by molecules of the dispersed medium, i.e. solvated. Due to this, the viscosity of the lyophilic colloid solution is generally relatively high relative to the dispersion medium. The next is suspended material. Suspended particles cause an increase in the viscosity. The viscosity of blood is important in relation to the resistance offered to the heart in circulating the blood. Suspended particles act as an obstacle to the blood suspensions, increasing the flow resistance, i.e. viscosity.
For question number 2, give the importance of rheology in practice of pharmacy. It is well known that the rheology is very important to every material because the rheological responses are closely related to final structures of the system. But beyond drug preparation, rheology gets applied in stress and strain measurements. For example, in products where crept and recover might essential properties in a material being used to restore tissue or muscle damage. Lastly, stability and porability of liquid preparations is determined by the viscosity behavior. So, rheology can be applied to solid, liquid, and gaseous states of matter. From a rheological perspective, solids are classified as being completely resistant to deformation, while liquids are being less resistant and gases are as being completely non-resistant for pharmaceutical applications. However, the discussion of rheology in this chapter focuses primarily on liquids and semisolids. For examples are creams, ointments, and gels. So here are the references. And here are the members and the contributions. Thank you and God bless.